As part of the UCS architecture, we have two distinct fabric interconnects in the mix. And the problem is those two fabric interconnects, they don't actually talk to one another. And we know we have communication paths through both of the fabric interconnects, so how exactly does communication happen between servers that are bound to the two different fabric interconnects via their different VNICs? Well, in this video, we're going to cover exactly how traffic flow works in a UCS environment. There's a fairly well-known line in the movie Shrek where he pulls out an onion and he's talking to his donkey friend and he says, ogres are like onions, and after some jokes about the donkey telling him, oh, because you smell like onions smell. He's like, no, because ogres have layers. And I feel like that every time I draw out a UCS infrastructure like this, I think of that line, like, UCS has layers. And it really does, right? Because we start at the top with the network, this LAN cloud. We've seen this so many times at this point. The two fabric interconnects, a chassis with its I/O modules, and then we slide a server in. That's the blue layer. And the server has a VIC, and we carve out VNICs. That's what the little VN blocks are. And then the hypervisor sees the VNICs. It doesn't see the VIC. It doesn't see the I/O modules. It just sees the VNICs. And it has V switches, and those plug into the VNICs, and those downstream to the virtual machines and the VM kernel ports, the VMKs. And the best part about all of this is that even though we live in a virtual world, it still translates back to logical network architecture. And so in this video, what we really want to cover is how does traffic flow work in a UCS environment, especially when it does connect down to a virtual hypervisor. So the first thing we need to keep in mind is that a VNIC actually attaches itself to a virtual Ethernet port. We've discussed this in previous sessions. And so when we have a vSwitch within the virtual environment, it really is connecting to a virtual Ethernet port. We can kind of ignore the VNICs, the VIC, the I/O modules. Those are all transparent from a network architecture perspective. So this virtual Ethernet port, or this VETH, is going to be really our switch port. Think of it like that. This vSwitch down at the hypervisor layer is connecting into our virtual Ethernet port upstream in the fabric interconnect. So that means that when traffic from a virtual machine gets sent out that link, it's really going to land on this virtual Ethernet port, and the fabric interconnect will then forward it up to the LAN if it needs to go to the LAN. Now, what if it needs to go back down into the rest of the networking world? What if this vSwitch and the VM on the right here, let's say this VM goes through a VNIC. We're going to say that's going through Fabric A, and it has its own VETH. Let's say maybe this is a VETH, well, we'll call this 701 and this one 703. So what's a switch do with traffic? Well, it likes to switch it. It likes to switch it between Ethernet ports, or in our case, virtual Ethernet ports. So what UCS is going to do is it's going to receive the traffic from the VM on the left. It's going to forward that traffic to the other virtual Ethernet port, which will send it right back down to the other virtual machine. So one thing to note, first and foremost, is that these two virtual machines, even though they're on the same server, the same physical hardware, it has to go all the way up through the I/O modules and out to the fabric interconnect in order to get switched back down. And that's because they're on different vSwitches. If the virtual machine was attached here to this vSwitch, the hypervisor does a good job of just keeping that traffic internal to the server. But anytime we have virtual machines on two different vSwitches, well, it's a different situation. It has to get switched off of the host. Now, let's also keep in mind that we have two different fabric interconnects. And so the way the VNICs are configured, we typically will pair them up such that the VNIC on the left maybe here in our drawing is on A, and the VNIC on the right is on Fabric B. And what that means is this VNIC is pinned to a VETH port on Fabric Interconnect A, and this VNIC is pinned to a VETH port on Fabric Interconnect B. Now, what if failover is enabled? Well, we covered this. We use the dotted line, right, to represent that, hey, that's connected over to a VETH port that's on B, but that's not active right now. So even if failover is configured, we actually don't worry about that, because a VNIC can only be bound to one fabric at a time. So here's the question. What happens if we need to go from a VETH port on Fabric Interconnect A to a VETH port on Fabric Interconnect B? And a realistic reason for this might be that we're going to try to communicate between these two virtual machines down here, and this virtual machine is actually pinned through the B VNIC, which means that this VNIC is on a VETH port on Fabric Interconnect B. And so our goal is to get traffic between this virtual Ethernet port and the one on the right. So how does a Fabric Interconnect with no direct path between the two Fabric Interconnects get it to the other Fabric Interconnect? Well, we see it right here in our solution. It has to go through the LAN in order to get over to the other Fabric Interconnect, which means, if we think about this, to communicate between two virtual machines on the same hypervisor host, it has to go all the way up through the I/O module, through the Fabric Interconnect, through the LAN cloud, down through the other Fabric Interconnect, down through the VNIC, through the vSwitch, and to the other virtual machine. That is a lengthy trip for two VMs on the same host. This is why it's very important to understand UCS traffic flow, because we can be intentional about this. And if we're not, we might end up with some traffic flows that are far from ideal. It's mission critical for us to understand how traffic flow works in a UCS environment. For VNICs that are bound to the same Fabric Interconnect, that traffic will stay on the Fabric Interconnect. It will never hit the network. But for VNICs that are bound to different Fabric Interconnects, even if those VNICs are on the same physical server, that traffic is going to go through the network. I hope this has been informative for you, and I'd like to thank you for viewing.